Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone. Welcome to our three-part series about hosting your Python agents on Microsoft Foundry. This is day 2 of the series, and we have one more day after this. So for our first day, we talked about Microsoft Agent Framework and how to take agents and workflows built in Microsoft Agent Framework and use those with all the Microsoft Foundry offerings. Today is all about LangChain. Now, if you did join us yesterday, we're going to cover a lot of the same things we talked about, in the first session, but today we're using a different framework. We're using LangChain. So if you're joining us for day 2 and you were here for day 1, welcome back, and you're going to learn a couple things twice. Yay! And then day 3 will be completely different, talking about evaluations, which is one of the topics that I am the most excited about. So if you have not registered yet for the series, you can do that with the URL that we're putting in the chat, and then you'll get notified about the final session. And here is to start our slides for today. If you want to download the slides for your own use, we will share this link for the slides in the chat, and you can follow along there. We are going to be talking about all things LangChain. So how we can, what are agents? How do we build agents with LangChain? How do we add in different components from Foundry? How do we host those agents? And then how do we actually build workflows using LangGraph and then host those? So for today, our demos are all in this repo. So this is a new repo, different from Monday, our day 1 repo, because that one was Agent Framework. So we have a repo specifically for today with all the LangChain related demos. So if you want to follow along, do check out this repo, clone it, fork it, and then you'll need to run AZ up in order to actually get everything deployed that it needs. All right, so let's just talk briefly about agents. An agent is a piece of software that is using a LLM in order to achieve a goal by having the LLM call tools. And it does this in a loop until it finally reaches the goal and has run out of tool calls that it wants to make. So that's the most basic version of an agent. We often add in things like memory, short-term and long-term memory, dynamic memory. We might add in planning, or we might just use a reasoning model. We might also add human in the loop in order to confirm that we really want to go through with a tool call. So if you do want to dive much more into agents, check out our previous series where we spent 6 sessions going much deeper into agents. Here's just an example of the agentic loop, right? We have our system prompt. The user asks the question. The LLM says, oh, okay, I'm going to call this tool here to help answer this question. It gets back a true result, and then the LLM can answer based off the true result. And then this conversation can keep going and going and using different tools in order to answer all of the user's questions. There are multiple agent frameworks that you can use to build your agents. For this series, we're focusing on Agent Framework and LangChain. Those are some of probably the 2 most popular ones from our audience. But there's also Pedantic AI. That's also a fairly popular one. And I know Pedantic AI, you can integrate that pretty well with Foundry as well. So, there's many frameworks out there that can help you with, building your agent, building the harness. Now we talk about harness engineering. So, these frameworks are taking care of your harness engineering for you, your context management, your context engineering, right? all of the new, new considerations that we have to think about when we're building an agent, right? And they start simple, but then they can get really, really complex when you start getting to more sophisticated agentic architectures. So today is all about LangChain and LangGraph. In the chat, if you're already using those, please share what you're using them for. Share why you like them. These is very popular frameworks. So they both come from the LangChain company, and they have an interesting history. Like LangChain was basically the first open source library for working with LLMs, and the first version of LangChain, like LangChain V0, had like a crazy complex code base because everybody was like sending it PRs left and right to do this X, Y, Z, right? And had all these different ways of doing things. And it did get like a little out of control. At a certain point, they came out with LangGraph because they realized people needed to be able to do things like workflows, like multi-node workflows that were, chaining together, different, chaining together an agent with a processing node with an agent, right? And then they took the original LangChain and they completely revised it and made LangChain V1. So that is what we're focusing on today, is LangChain V1. And now the interesting thing is that LangChain V1 is in fact based on top of LangGraph. So LangChain V1 is designed to be like the easy way to do the common thing of building an agent. And so that's what you're going to start with. If you are building a single agent that has access to a bunch of tools, you start with LangChain. And then once you start needing to piece together to make a workflow that has multiple agents and other nodes in it, that's when you might move to LangGraph. But we're going to start with LangChain. That's what we recommend everyone starting with. Now, when you're building your first LangChain agent, we'll start with LangChain V1, and then we'll move on to LangGraph at the end. Now, how do we install LangChain for Python? Where the main LangChain package is just called LangChain. So start with that one. For LangGraph, it's called LangGraph. Now, since LangChain is built on LangGraph, you actually probably don't technically have to install both of those. Could just install LangChain and it'll pull in a version of LangGraph. But you may want to have it as a specific other package if you're building LangGraph graphs. And then for today, we are going to be using the OpenAI provider package. So LangChain has a ton of provider packages, like dozens of them, because there's so many LLM providers out there. But for all of our scenarios, we can use the OpenAI package because all of the models that we're using today all expose an OpenAI compatible endpoint. So it's not that we're necessarily using all OpenAI models today, but we're all using models that are exposed with an OpenAI compatible endpoint, which means that's the only provider package that we need. But there are many other ones as well. So if you're working with an Anthropic or any other models, you could use that package. But for today, that's the one. Best practice is to always pin your versions and use a lock file. So for our example, we actually have this pyproject.toml. So we declare all of our dependencies in here. So you can see I've got LangChain, I've got LangChain OpenAI, I've got LangGraph, and these ones I just have the greater than or equal version specifier on them, saying like, oh, this is the oldest possible version we should use. But then what I also have is a uv.lock file. So we use uv instead of pip, and uv makes this lock file. And in this lock file, you can actually see, let me find there, it's right there. What it'll do is say, okay, we are using exactly 1.2.15. Here is the exact, wheel and zip file for that version of the package. So, it's remembering exactly what version we are using. So you definitely want to do that. That way, you don't accidentally, bring down a newer version of the package and not know that. But for multiple reasons. One is that new versions may just be backwards incompatible, right? There might be something that breaks your code. Obviously, you don't want to break your code. Two is security vulnerabilities. We've had so many instances this year where packages have been compromised and the hackers have pushed new versions of the packages to PyPy that have vulnerabilities in them. And then if whoever doesn't have it pinned, this happened with Light LLM earlier this year, they didn't have it pinned and they did, a pip install, then suddenly they've got this compromised version of the package that can do all kinds of things to their computer. So you really want to pin your versions, use a lock file, and also just probably like wait a day after each version release, just to see, if there's any vulnerabilities in it. Okay, so now that we have it all installed, we can make a simple local agent with tools. So let me just show the code for that. Right. So you can see, we bring in various things from OpenAI, the chat OpenAI constructor, create agent tool. And then here we set up this chat OpenAI constructor, and I'm pointing this at a local host URL. This is the Ollama local host. So for this first example, I'm actually using a local model that's just running on my machine using Ollama. You could also use Foundry Local, LM Studio, anything that can run local models, right? So just if you want to start local and not have to deploy any models. So here it's pointing at my local machine. Doesn't matter what the key is because it doesn't need a key. And then for the model, I'm using Qwen 3.54b. This is a good, the best model that I can run on my machine for agentic tool calling. I don't have a very capable machine. I only have 16 gigs of RAM. I'm working on upgrading that. But for this machine, that's the best one. You can, if you're curious, you can go to canirun.ai and it will look at your machine stats and then try to estimate what's the best. So you can see for this one, it says, okay, Qwen 3.5, Llama 3.8b are pretty much the only two here that it recommends. And we did various side-by-side tests and found this one works best. Okay, so we create that. We're telling it to use the responses API instead of the chat completions API. And then we create an agent. So this is using LangChain's create agent. We pass in the client information so it knows to connect to the Ollama URL. We pass in a list of tools. So if we go back, we can look at this tool. So this tool is just a locally defined Python function. So that is one way that you can provide tools to your agents is just you write a Python function. That Python function does whatever it needs to do. You wrap it with the @tool decorator, and that comes from LangChain. So you wrap it with that @tool decorator, and it's going to take in some args. It's going to have a doc string. Now, whenever you write a tool, you want to put a lot of effort into the tool name, the tool arguments, and the tool doc string, because that is the information that gets sent to the LLM when it's trying to decide, like, hey, is this the tool that I want in order to answer this question? So in fact, your function signature is a form of prompt engineering. It's not just for your Python code, it is for the LLM. It gets turned into the tool schema that the LLM sees. So here we give it the list of tools, and then we have our system prompt, which is of course also a form of prompt engineering. So I say you're an internal helper, here's today's date, use the available tools, and always ground your answers into results. And then finally, when we run the code, we invoke the agent and say, hey, when does benefits enrollment open? And we get back results and we show it. So here I've already run it, so you can see that we can actually see the post that it makes to the local model. So it made the first call to the LLM to say, hey, LLM, I have this question from the user. How am I going to answer this? And the LLM said, oh, okay, actually, let's call this tool. And so it goes into here and calls the tool. And then that tool result, which is this JSON here, gets sent to the LLM. And so now the LLM sees, oh, okay, we want to know when does benefits enrollment open. I see this tool result here. And then the LLM answers, all right, based on that timeline, the benefit enrollment opens here, right? So this is our most basic agentic loop where the LLM sees the request, sees the tools, decides which tools to call, gets back the response, and answers based off the tools. All right, so that is all working locally with LangChain and Ollama. Now, let's talk about the point of today, which is how can we start building these agents on Microsoft Foundry instead? So Microsoft Foundry is a whole platform with many components to it to help you build your AI-based applications. And we're going to attempt to bring many of these components in today. So there's Foundry Models, and that's what you often start with, is just being able to access the really good models. So we've got the GPT models. Now we have GPT 5.5. Actually, now I have to update the slide because there's new models every week. We have the Anthropic models as well. We've got actually thousands of models because we've accessed all the Hugging Face models as well. So you can access many, many models from Foundry Models. Then we have Foundry IQ, which is based off Azure AI Search, which helps us bring in data for our knowledge retrieval, so for RAG applications. Then we have Agent Service, which is hosting the agents, and we'll see that today. And we have Foundry Tools, which is just all sorts of tools you can use that are built in that connect to different services. So we're going to use a couple of those today as well. So when we are using LangChain with Foundry, we do recommend using this package that we maintain on the Microsoft side. So that's LangChain-Azure-AI. Because that has a lot of tighter integrations between LangChain and Azure to try and make it easier for LangChain developer, people using LangChain to also use Azure and Foundry. So you definitely want to look at that package and install that into your environment and see what you can use. And we're going to use various parts from it today. So it also has some extras, as they're called. So when you install a Python package and then you put something in brackets, that is called an extra. So some packages are designed to have extras so that they can have like a core part. And then if you want an extra, you say, oh, I want this extra component. And then it brings in more code and more dependencies. So with that package, we're also going to install the OpenTelemetry extra, and that's going to help us emit traces for App Insights. And then we're also going to install the new Tools extra to help us integrate with Foundry Tools. But there's lots of other parts of that package. And then there's also some sibling packages here for different parts of Azure. So there's Azure Cosmos DB, Azure Postgres, Azure Storage, SQL Server, Dynamic Sessions. So trying to make it easier for folks to use LangChain with Azure, because there's actually just a huge number of developers that are combining LangChain and Azure together. The LangChain team shared some stats the other day, some graph that showed the number of calls from Azure. And it's pretty staggering. So that's why we're doing, that's why we're trying to make it easier. That's why we're doing today's session, because we know it's so popular. Hopefully we can just make it easier for you. So in that LangChain Azure AI package, this is just high level, some of the integrations that you can find there. Some of them we'll be using today, like Foundry Tools and the OpenTelemetry tracing. But there's also helpers for doing RAG and document ingestion. There's also helpers for doing AI content safety and guardrails and middleware. So lots of fun stuff in that package. So now that we have that package, so you can see I have that in the Pi project. We've got LangChain Azure AI with the OpenTelemetry extra here. So now we're going to talk about Foundry Models. So I was saying we do have thousands of models, and including some of our favorite models like the Anthropic models and the OpenAI models. We also have the Kimi models; those are cool. So when you're exploring the models, we've got leaderboards where you can check out, who's the best in quality, safety, cost, throughput, etc. Or if you're trying to decide just between two different models, you can actually compare side by side, like, oh, hey, how do they rank for those, right? And you'll see this is where you're going to see their overall metrics. Now, if you're really trying to decide between two models for a particular application, then you really want to write evaluations for your application and do a true side-by-side comparison for your domain, right? Because all of these leaderboards they're pretty generic, right? They're like, okay, well, generically for quality, right? But like you're all writing all sorts of different interesting applications in different domains. So you're not necessarily going to see the same results. So that's why you should come tomorrow where we talk about evaluations, because that's how you really get to see like, okay, how is this model specifically handling my scenario? So how do we use a LangChain agent with Foundry Models? We only have to change the very top of the code. So we're going to use that chat OpenAI constructor again. So the same constructor, and we just have to change the base URL. So here you can see, instead of pointing at a llama, I'm pointing at my deployed Azure OpenAI endpoint, and then /OpenAI/v1. This is our new way of forming the OpenAI endpoint when you're using OpenAI models on Foundry. And then, so then we have that. So that's our base URL. Then we can pass in our API key. And in this case, I'm actually passing in a token provider callback function that's going to give an Entra token. So that way I can do keyless. So it's up to you what you want to use, but we try to use keyless whenever we can. But you can also just pass in an actual key from your Foundry environment as well. If you're using keys, I usually disable those, but you do you, and then just really take care of your keys. And then we say what model we're using. Now, when we specify the model, we're actually doing the name of the deployment. So one thing that's confusing on Foundry is that we have the models, and then you actually have to deploy the model, and then you have the name of the deployment. Now, what I usually do is I try to match the deployment name to the model name just for, consistency in my head. So a lot of times my deployment name will be the same as my model name. So this would be like GPT, -5.5, right? If that was my deployment name. So that's it. So that gives LangChain enough information to know how to make calls to that OpenAI compatible endpoint. So let's go ahead and look at running that, right? So, and this is, really similar code otherwise, right? Same tool. Really all that's changed is that now, we've got that token provider that's generating the keyless credential. We've got that OpenAI constructor, and then the rest is all the same. So when we look at when it runs, you can see that this time it's making a post to my Foundry OpenAI account here, right? So this is actually posting to that OpenAI model on Foundry and getting back the response. So, if we just compare it here, it's the same sequence of calls and, same tool call in the middle. We do get a slightly different answer just because each LLM has their own flavor, right? In this case, I'm using GPT 5.2, and GPT 5.2 is quite serious, quite stoic. So it gives me just the answer I was asking for, and, isn't all flowery like the other one. But, every model has their own way of being. So there we go. So now we're using Foundry Models. Next, let's talk about Foundry IQ. So Foundry IQ is a way of doing knowledge retrieval using Azure AI Search knowledge bases. So Foundry IQ is basically the name for Azure AI Search when you're using it in this certain way. It's kind of a marketing thing. But anyway, so currently you just think of Foundry IQ as, using Azure AI Search knowledge bases, from Foundry. So the way it works is that we make an Azure AI Search knowledge base, and a knowledge base is composed of multiple knowledge sources because it actually do multi-source parallel retrieval, which is really nice. So your knowledge sources could be a search index, it could be SharePoint, it could be an MCP server that's in private preview right now, but you can compose all these knowledge sources together, and then AI Search will take care of searching those in parallel, getting back the results from all of them, merging the results, and even re-ranking the results using a re-ranking model to figure out okay, for this query, which results are actually the best across all of these sources. And then there's an MCP endpoint for this knowledge base. So we are going to use this knowledge base via its MCP endpoint. So it exposes its MCP server that has a single tool, knowledge base retrieve, which takes an array of queries. So that, the agent is going to see, okay, I've got this retrieval tool. The retrieval tool accepts a list of queries. All right, based off what the user is asking, I think we should search, X and Y. I'm going to send this, list of queries to this tool on this MCP server. Then AI Search is going to send that query out to all of the connected knowledge sources at once in parallel, merge back the results, and then those results go back to the agent. So that's generally how it looks like. How do we actually integrate that? So for this, we're going to set up an MCP client in LangChain. And this one, we actually do need to bring in a another package, which is the LangChain MCP adapters package here. And that contains the this multi-server MCP client that we're using. So we set up this MCP client and we say, hey, this is, we give it the server. So we say, okay, you've got this server. This is the URL for it. The URL is this AI search endpoint for the knowledge base /MCP. So that's the URL. And we pass in our auth as well, because we're doing keyless auth again, so that we're avoiding keys. And then we get the tools from that server. And when we create the agent, we also pass in those tools. So here this is called the unpacking operator. So we're taking this list of tools and we're adding it to this list here. So now the agent has access both to a local tool and a remote tool. And so it can decide for a particular question, like, oh, I'm going to use the remote tool. Am I going to use the local tool? I'm going to use both. It could use both for some of them, right? If it needs to, it could call them in parallel or in sequence and answer the question. So we're giving it more options here. I see we want a larger font size. Let's see what we can do. Okay. So let's check that out. So here I'm running, I've run it. And what's interesting here is I have enabled quite a lot of logging just so you can see what's going on. So it does make a lot of HTTP requests to that MCP server in order to set up the connection to the server. So it says, oh, hey, server, hey, what tools do you have? What protocol are you using? So it's basically doing like a handshake. So you can imagine anytime an agent is using an MCP server, it has to do a bit of a handshake with that server to say, hey, who are you? What tools do you have? How can I use you? So that's what all these calls are for, is doing that handshake and figuring out the list of tools that are available on that server. Then finally, it can send a request to the actual LLM and say, hey, here's the tools we have. Here's the user's question. And here you see this question is basically a joint question where it's going to need to use multiple tools. And so it calls the local tool, and you can see that it does also call the MCP endpoint as well in order to get back a response. And so then finally sends that to the LM endpoint. So then we get back an answer that references what's in the knowledge base. That's what all this is from the knowledge base. And then also the enrollment deadline, it said, okay, this is what I found for the enrollment deadline, and that came from the local tool. So that's pretty neat, because now we are actually grounding our agent in, in answers from our knowledge base. And these knowledge bases are really, really powerful. Because you can hook them up to so many different, so many different kinds of knowledge sources and set up different ingestion pipelines. So there's quite a lot you can do with these knowledge bases. Okay. Now let's talk about Foundry tools, because we've got some great knowledge now and we've got some local tools, but there's other sorts of tools we might want to bring into our agent. Foundry is trying to make that easier by having a whole Foundry tool catalog that you can pick tools from. And now they have something called Foundry Toolbox. This is very new. But with Foundry Toolbox, you can basically say, hey, I always want to use this bundle of tools. I'm going to package these together into a toolbox, and it will expose a unified MCP server around those tools that then lists all of those tools, right? So then our agent can connect to that MCP server and have access to any of the tools that are in our toolbox. So that's how we're going to work with the Foundry tools today, is by making a Foundry Toolbox. And what's cool about the Foundry Toolbox is that it can use any of the tools from the Foundry tool catalog. It can also use any MCP server that is out there. So it's designed to be fairly flexible. For today, we're going to make a toolbox that has my favorite tools. So it's going to have web search, so that we can actually search the web and get more up-to-date answers. It's going to have code interpreter, so we can do sandbox Python executions that run in these isolated VMs on container apps. And so that way you can, do more complex code, pandas, pillow, like all sorts of cool things you can do with code interpreter. I always use it to generate graphs because I love graphs. And then we can also add the Foundry IQ MCP to this toolbox, or we can use it separately. So I think actually in the code, I'm currently using it separately today. So how do we create a toolbox from code? So in this example, you can see how we first add in the two built-ins. And then if we do want to add the Foundry IQ MCP to the knowledge base, this is how we add it with this, this additional, addition to the list, which defines everything about it. So it's an MCP, this is what we're going to call it. Here's the URL, and it's using a project connection in order to handle the authentication here. And then we just use the Toolbox CRUD API, the REST API, in order to make a new toolbox and say what our default version of the toolbox is. So we're using the REST API here because we don't have an SDK to do this yet. In the future, we should be able to use a Python SDK in order to do this more easily. Next, we need to equip the agents with the toolbox. And this is where that LangChain Azure AI package becomes really handy because it has built-in support for the toolbox. So we're going to import from the LangChain Azure AI this project toolbox, and we just say, hey, here's our toolbox name, here's our credential. Let's get back the tools from that toolbox, and then let's pass those to our create agent. So let me also show that code locally here. All right, so here we've got our toolbox, and we passed all those toolbox tools in, and then here I'm asking a question that's going to require a web search. So now looking at the actual running code for this, and I enabled a lot of logging once again to show you. So I said, all right, we're going to run this Foundry toolbox, and you can see it makes a lot of requests. So once again, since the toolbox is an MCP server, the agent is going to start off with a handshake that says, all right, hi, MCP server. What tools do you have? You can see loaded 2 tools from Toolbox. So it found, in this case, I only did, I changed my toolbox to only have web search and code interpreter. Because there is actually currently a bug with using the MCP servers in the toolbox. It should be fixed this week, but not yet today. So here I just have 2 tools, right? So it loads those 2 tools from the toolbox, and that's what this MCP server is exposing. Then, we make the request to the LLM, and the LLM decides it's going to call the tool from the toolbox. And in this case, it's going to use the web search tool. And that way I can find out the weather today. It looks like it's going to be nice outside. Maybe I can do a little bit of gardening. Oh, and air quality looks good too. Sweet. So there we go. So that was an agent. Now the agent has the ability to search the web, and that's really nice because it can start grounding its information whenever somebody's asking about something about like current events, news, that sort of thing. Okay. Now let's talk about Foundry Agent Service. So Foundry Agent Service is a way that you can then take these agents and actually host them, right? Because you see all those agents I was running them locally, right? That was just saying, oh, UV run this agent, right? Which could be fine for some of your agents if they're just to, for your own productivity locally. But many of agents you're going to actually want to run on a server in production so that other people can access them from different endpoints. So that is the goal of Foundry Agent Service, is to make it easy for you to host your agents with production grade technology. So there are 2 different types of agents in Foundry Agent Service. One is prompt agents, and those you have to use you have to use the Azure AI Project SDK to make them, and you have to say, okay, here's my system prompt, here's my tools, and they're pretty limited in that basically all you get is the ability to say prompts and tools, and you can't customize it that much because those agents are actually running a agent loop in the cloud. Their loop is like a service that's running on Foundry, and you don't have that much control over it. So you can use those. I mean, if those work for you, great. You can use those. I like the idea better of hosted agents because then we can bring our own agent frameworks to it, and And then we have more flexibility. As a developer, I always want to have more flexibility, but I also, want easy hosting. So that's the goal of hosted agents. It's very new, so it's in public preview right now, and the brand new version just came out last week where it's running on a new platform. And so it is very new, and it does have rough edges right now, but generally I like the idea of hosted agents where we could bring our own agent framework and we have much more flexibility as a developer to be able to do what we need to do in our agent code. Now, both of these should be able to use all these different components of Foundry, right? So we saw Foundry Tools, Foundry IQ, Foundry Models. There's also Foundry Memory. I saw we just had a question about that. We don't have Foundry Memory in the sessions of this series, but there are definitely code examples that show you how you can use the managed Foundry Memory service. There's this like Foundry Memory Store class that you can use. So that is another aspect of Foundry that you can use with your agents. And then, once you do all this, then you get observability and security and everything on top. So today we are focusing on hosted agents and being able to bring our LangChain agents to Foundry Agent Service and still get hosting from it. So how does this work? So generally, here's the idea behind the hosted agents for Foundry Agent Service. So you have some code, it could be in any language, right? I even know my .NET and Java colleagues have been messing with it this week. So you've got some code in some language. In our case, it's Python. Now that code, we need to expose it in a way that's compatible with the OpenAI Responses API, right? So if we can, and this is a well-documented API because there's also an open responses spec because they're trying to make it a standard. So we need to expose it in a way that's compatible with that responses API so that it accepts input in the form of, responses input, and it outputs in the responses output. And then we make a Docker file that can run this server that, is a responses server. And once we have that container and, upload that to Azure Container Registry, then Foundry Agent Service can run that container. And as long as everything is compatible with what Agent Service expects, then you get lots of benefits out of the Agent Service. You get easier observability, you get a playground, you get evaluations, you get all sorts of fun things in Agent Service. So this is the option if you're doing Responses API. There's also a more generic invocations API where basically you just need to expose an HTTP endpoint, right? If you expose your server and your server would just take whatever, right? Like maybe it accepts files, maybe it accepts audio, like who knows, right? So with that one, you can also run that on Foundry Agent Service as well. You won't get as many of the as much of the built-in functionality as Foundry Agent Service if you're not supporting the responses API layer there, but you can still host it on Foundry Agent Service and still get some of the benefits. So generally, if you are going to use hosted agent service and you're bringing your own agent framework, you're going to have to decide, do I want to, make it work with the responses API, or am I happy to just use this generic invocations API? For this series, we are focusing on the responses API because one, it's harder, so we'd rather help you figure out that harder one. And two, it's more powerful. Once we have it figured out, we get way more functionality out of Foundry Agent Service. So how is this specifically going to work for LangChain and LangGraph? So what we have is an adapter, written by our colleague who's also part of the community, but we've written an adapter and we've got the code in the repo that basically creates the responses layer on top of a LangChain agent. And, so what we do is we create our LangChain agent, and then we bring in our adapter class and say, all right, adapter class, here's the agent, run this agent and expose it as a responses API endpoint. And then we have also a Docker file and an agent.yaml, and we can upload all that. So let me show that code. Okay, so you can see here, we create our agent, and this is, basically what we did before with creating an agent. But now this time we wrap it in this adapter class. And this adapter class is we just have it checked in here. It's from this module here that our colleague wrote. So we bring in that adapter class, and it exposes the agent behind a responses API layer. And then we have a Docker file, and the Docker file says, okay, we're going to install Python. We're going to, bring in our dependencies. We're going to run this code here. And so that'll start up the server. Next, we also have an agent.yaml. This is required for deployment. You can see I have a little thing that says deploy. And this agent.yaml says, all right, here's the name of our agent. That's how it's going to show up in Foundry. Here is the protocol we're using. So here we're using responses instead of invocation. Here's the resources we need for the micro VM that each session is going to use. And here's any additional environment variables that we want injected into that container when it starts up. So that determines how it gets deployed. And then also we have an Azure.yaml, which says which agents get deployed. So that Azure.yaml, once again, references that agent name, says, okay, you're going to deploy this agent using the agent platform. You're going to build it with Docker, and here's the startup command. There's a little redundancy between these two files, and we're working on the redundancy, right? Like the resources, startup command. But this is currently what you need in order to be able to run, to deploy these to agent service. So how does that adapter work? I mean, generally the idea is that we need to take the LangChain, the shape of the LangChain API, and we need to turn that into the responses API, right? So when we get input, because the input always comes as responses API input. So when we get that input, we then convert it into the LangChain equivalent. So, for responses API, it's, message text content, and we turn that into human message for LangChain, which I like that class name actually. And then similarly, if it's, it has a different role, then it becomes an AI message. System developer role becomes a system message, right? So we have to translate our input into the LangChain equivalent so that we can then pass it to LangChain. And then for output, similarly, we, we have to do translation there as well. So the general idea is that, we're turning these LangChain classes into responses API input and output. So here's the overall code that we need, right? And we basically already saw this, but we create the agent, we wrap the agent in that responses host, and we run that server, and that starts running the responses API endpoint. Then in order to deploy it, we are using AZD, the Azure Developer CLI, and AZD looks at all those files I just showed you. So it's going to look at the Azure.yaml in the root. It's going to look at the Docker file. It's going to look at the agent.yaml. And so, and it's also going to look at all the bicep. So we have a lot of bicep files. That's infrastructure as code. So there's a ton of bicep files in our repo. But AZD can also write those. So if you're starting fresh, AZD can help you write those bicep files too. We've already got our bicep files here, but when you're building a new one, it can actually help write you those files. So it provisions all the infrastructure using the bicep files. Then it builds the Docker image based on the Docker file. It pushes that Docker image to the container registry. And then it deploys the new agent version to Foundry. It says, hey, Foundry, we've got this new agent version. It's based off this, this image. Here's the new version number, right? And then Foundry has this new version. So I have, let's see, I ran it earlier today, so I can show you, what this looks like when we do AZD up. So AZD up, we'll start off with the provisioning. So you can see when it provisioned, in this case, it needed to provision the Foundry model, provision some app insights. It provisioned the Foundry project. It made a storage account. It made some connections. It made the search service, since we're doing Foundry IQ. It made the container registry, made some more connections. Then I did a little post-processing just to set up that index, right? So this is how I created my index. I did some uploaded to the search index. Then I created the toolbox, and then it deployed the agent. So in this case, we're deploying both an agent and a workflow, because we're going to talk about workflows soon. So it said, all right, I'm deploying this agent. This is how you can access the agent. So it has a link so that you can just play with it in the playground, which we're going to do in a second. And yeah, each of them has a link. Okay, so that's generally the process. My process is a bit longer because I am doing all this setup of Foundry IQ and Foundry Toolbox, and I like to incorporate that into the deployment. The basic thing is, doing that provisioning and then doing that deployment. Okay, so what's fun, like, as soon as you deploy it, the first thing I usually do is I go over to the Foundry, I go to the agent, and here's the playground, right? And so here we have a question, right? This is my joint questions. So what perks plus benefits does Zava have, and how does that compare to other companies? So I like this question because it requires both Foundry IQ and web search. So it should have to, use multiple tools. So you can say, okay, from our internal docs, this is what we know about the benefits, and then how that compares to other companies from external benchmarks, right? And this is what it actually got from the web search. And what's cool is that you can also just see the logs from this container. So this is running on our new very fast micro VM platform that starts up really fast and isolates, the sessions for each user. And it shows the logs for each of these sessions. So as you're playing in the playground, you can see all of the logs come through. And I love logs, so I have a lot of them. So these logs can be really helpful, especially if there's an error. So, of course, always check your logs, or, copy paste them, give them to Copilot and say, hey, help me with this error. I'm doing that all the time. Now, what's also cool is that we can, we can also look at the traces. Actually, we'll talk about that in a sec. Okay. So yeah, so here's the playground, and it's a fun way to test it out. Is just play around the playground, and anyone who's in your tenant can play around. So this is actually Gwen's agent that I'm using here, because we're all in the same tenant. So I can experiment with Gwen's agent in her playground. Now, of course, practically when you're running something in production, you're not just going to be using a playground for it, right? You're going to actually want to use that agent to integrate with other systems in some way, right? So when you want to use it, you're going to interact with it using the responses API. So here's just a curl request that goes out to the endpoint that sends it some inputs, right? So you can use this HTTP API from anywhere, for however you want to integrate it, you can use it. We have a specific example that uses the Azure AI Project SDK to basically, make a request using the OpenAI Responses client. And, so that's one easy way of interacting with it, but this is an API, so you can use it however you would like. There is also a local development loop because, of course, when you're developing things, you don't want to have to deploy every time you make a change. So what we have is two commands. One of them is AZD AI agent run, and that will run your agent with a local responses server. I think I have that here. Yeah, so you can see running on, on localhost 8088. And so that way it can take requests. And so then when we want to invoke that local server, we can use AZ AI agent invoke -- local and say, pass in our question, right? So here I just said hi, but you can get back a response from it and check our logs as well. So generally when you're developing, you're going to be using this local development server in order to, test your changes. And then you only want to deploy once you're actually feeling good about them and, feel like everything's working well locally. So now let's talk about observability. Oh, I realize we have 10 minutes left, so I'll be fast on this. So for observability, we like to use OpenTelemetry in order to output all of our traces. In order to do that with LangChain, we are going to use that LangChain Azure AI OpenTelemetry extra. Remember that we installed that, and that has this enable auto tracing function in it. So we call that enable auto tracing function in our code. You can see, actually, we have a few more options that I passed into it. Where did I put it? Enable here. So enable auto tracing. So I passed in the connection string. This gets auto injected into the container by the platform. I said, I want you to configure Azure Monitor. So it's going to export to Azure Monitor based off that connection stream. It's going to record all the content. That includes tool calls and arguments, which could be sensitive. So you don't always want to record them. Trace all LangGraph nodes. And then I gave it an ID. So that's the setup that we're going to do that's going to emit traces using OpenTelemetry in a standard way that's going to work with App Insights and also as well work with Foundry. So there we go. So that will take care of it. And then once that's being output, then you can go to Foundry and you can go to this Traces tab, right? So here you can see Playground Traces. So I went to Traces and then Conversations. And then I click on one of these conversations and we can see all of the calls that went out, right? So we can see there's like invoke agent, and each of these calls, these have attributes, and these are all like standard attributes. So it's like, okay, this is the name of the agent. There's the version. Oops. All right. I probably just got logged out of Azure. So wait, I took a screenshot in case that happened. Here we go. So yeah, so you can see, we've got attributes for it. And we can also see calls to our LLM. We can see calls to each of the tools. So you can see first it did a knowledge-based retrieval, then it did a web search, and then finally did an LLM call. So this is super helpful to actually see what is your agent doing in order to answer the question, in order to get to the goal. And you can also see stuff like duration, decide, how's your performance. So yeah, so this is really nice. I really like having easy traces. You can also view these same traces in App Insights, and they actually have a really nice new agents view. If you haven't checked that out yet, it's very cool. It'll show you, it'll do like tool calls. Like this is a dashboard that's just already set up for you because it knows, because all this is done using a standard, this Gen_AI standard. So any agent that you're using with any framework, as long as it follows the standard for the traces, you can use this agents tab and it'll give you really nice dashboards. Okay. So finally, let's talk about multi-agent workflows with LangGraph, right? So a workflow is some sort of flow where you have agents at some point, but you also have a lot of other things potentially in that workflow. You might have branching, parallel flows, there's all sorts of things you can do in a flow. So for LangGraph, the way we make a workflow is that we construct what's called a state graph, and a state graph has nodes with edges between them. And these all are based off of state. So each node receives state, modifies a state, and then returns the updated state. And then the edges actually define the flow, and you could have conditional edges if you need to have branching. So this is almost the simplest workflow, right? So here we're not even using any agents at all. We're just trying to show the idea of how you build a workflow in LangGraph, right? So we have these two functions that have a state, and the state is just a dictionary that they're changing. So this uppercase receives the state, and then it returns back a new dictionary that has this text from the state in uppercase. And then reverse text does, same thing, receives the state and returns back a new dictionary that has the text reversed. So then down here, we create a graph, and we're saying, okay, we're creating a graph based off of this state. That's the state we're passing around. We're adding these nodes to it. We're adding an edge. We're saying, okay, the start node is uppercase. Then there's an edge between uppercase and reverse text. And then finally, the reverse text goes to the end of the graph, right? So you define your start, your betweens, and your end. Then we compile the graph, and then we can invoke the graph with some input, right? And here the input matches the state. So let's see. Oh, I didn't actually run. Let me see if I can run this here. UB1 workflows, stage 0. Stage 1, simple nodes. Okay. All right, very exciting. We got back uppercase reverse text. Okay, That's your basic workflow. This is just to explain how LangGraph works if you haven't made a LangGraph graph before. Now, how do we actually use LLM calls inside workflows? One way is that, inside your workflow, you would just call the LLM or call the agent, right? Like it's just having a call to an LLM inside a node. That's kind of the most straightforward way of doing it in LangGraph. So here we've got these nodes, the writer and formatter. The writer makes a call to an LLM that asks it to do some writing. The formatter says, okay, you're going to add lots of emojis because of course we love emojis. And then we come up with the same kind of graph. The difference now is that these nodes have LLMs in them. Let's see if I can run this one. Let me open it. Okay, stage 2. Agent nodes. All right, so it gets the prompt. Yeah, sorry, I can't run it because I've been logged out of my Azure account. I thought that would happen. All right, that's why I had everything preloaded. So apologize, can't run that right now. But basically we would get back the formatted result. Now, how do we host this on Foundry? It's basically the same story as before. We're going to bring in that responses adapter. We're going to wrap the graph in the in that adapter. So basically the adapter knows how to work with graphs or agents. It thinks of them as being the same. And then we're going to run that server. And then we deploy it. So basically we have the workflows in its own folder. So in the workflows, it's got its own agent.yaml. It's got its own Docker file. So that's one takeaway as well, is that you can basically have a mono repo where you have multiple agents and workflows that are being deployed as different Foundry agents. Just each file needs to have its own Docker file, an agent.yaml, and then your root Azure.yaml needs a reference to that, right? So you can see, hosted LangGraph workflow, and it has information for that one, right? But that's nice because a lot of us, I think, do work with mono repos where you want to be able to deploy multiple services in the same repo, and you can do that here. All right, so I have that deployed over here. So I said, write an ode to dark chocolate honeycomb, which is something I just discovered. And you can see it came back with this lovely ode that has lots of emojis and lots of markdown. I love when I have it write poems. Okay. So there you go. So we've shown you how to use LangChain and LangGraph, but I want to preface again, this is really, really new, right? This new version of Foundry hosted agents just came out last week. We've been using it a lot. We've been reporting the issues with it because it's in public preview. The goal of public preview is to get feedback and to find out what things are working and not working. So if you do try it out, and if you have any issues, like if you have any issues with this repo, just file an issue in the repo. I was actually having some issues this morning. That's why I'm using Gwen's version of it. So, do file issues. The goal of this is to get feedback, during this public preview period to figure out, how can we make the platform better? What sort of, additional code or examples do people need? To be able to, empower you to do what you want to do. So please do file issues. So if it's with this repo itself, you can post in this. Otherwise, you can also post issues in the Foundry Discord, and we have folks who monitor the Foundry Discord, and they can escalate issues. So yeah, I encourage you to try it out, but also let us know what's working and not working. So next steps, if you haven't registered yet, register for tomorrow's session. There's a lot of really cool stuff to show in tomorrow's session about quality and safety evaluations. So I hope that you join us for that. That'll be all new stuff that we haven't talked about yet in this series. You can also watch the past recordings. So if you missed yesterday's and you want to check that out, I am linking to everything from the resources page. And I think we've put that link in the chat. But basically, for every session, we've got YouTube, we've got slides. We also have these like write-ups that I make. So the write-ups have like annotated versions of the slides. So you can go through those. We've got the office hour recordings. We've got write-ups of the office hours recordings. So we try to be really, really thorough and give you as many resources as we can. You can also post issues to this thread. So if you post an issue to this thread, then I will see it here, or you can just post an issue just generally in this Foundry discussion forum. I'm just trying to give you lots of places to file issues so that we can get more of your feedback. And then now we have our office hours. So after every session, we do have an office hour. So come on over to the Foundry Discord for office hours. Our office hours there's 2 channels for office hours in the Foundry Discord because there's just so many all the time. So ours, I think, is in the community calls 2 channel. So hopefully you don't get too lost. If you find yourself in something that doesn't look like me talking, then just switch channels. So I know I didn't get to answer most questions or maybe any questions in the chat today because we had so much to cover. But we do have the office hours now, so I encourage you to come on over to the office hours and ask me your questions there. And I hope to see you there or see you tomorrow. Thank you, everyone. Bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.